Good evening, ma'am. I'm Roshni and I'm from Caa-Ii section. My roll number is 2440105W7. The course code is 23MET02 and the subject name is Differential Equations and Vector Calculus. The question which I got and the topic is work done by a field along a straight line. And the question I got is calculate the work done in a moving particle in the force field 3x square I plus 2xz minus yz bar plus zk along the straight line from the point 0, to 2, 1, 3. Introduction to work and line integrals. To determine the work done by force, we use the concept of line integrals. The approach is especially useful when the force is not constant or when the path is not a simple straight line. A line integral sums up the final estimation amount of work done along the path. Here, work done by a force. In physics, work done is a force causes a displacement. For a variable force along a path, we use a line integral, and the line integral definition is the work done W by a force field along the curve C is given by W equals to integral C F d dr bar, where dr is the differential displacement vector along the curve. Understanding the force field. So I got the question as F bar equals to 3x square I bar plus 2xz minus y of z bar plus zk k bar. So let's understand the force field concepts here. Here we are considering that at I bar, before the I bar the term is called Fx bar. So Fx bar is 3x square, the component which is in ith direction, and Fy bar is 2xz minus y of z bar, so the component is in the z direction, and Fz bar equals to z, which is the component in the k direction. Interpretation is this force field depends on the positions of x, y, z in space. The force in the particle changes as it moves. Parameterizing the straight line. To integrate along the straight line from 0, to 2, 1, 3, we need to parameterize the line in terms of a single variable t, which ranges from 0, 1. The transforms the problem from integrating along spatial path to integrating over a scalar variable. The straight line is described using the vector equations as the parametric t varies from 0 to 1. Vector equation of the straight line R of t is 1 minus t of a plus tb. This is the equation, and applying to our problem, we got a is the points 0, 0, and b is 2, 1, 3. Now we are applying this formula. R of t is 1 minus t of 0, 0, plus t of 2, 1, 3 is we are multiplying that. That's it. This becomes 0. That's 2t plus t 2, 3t. That's it. So x equals to t, x equals to t, y equals to 3, and z equals to 3t. Now finding the differential displacement of vector dr. Now the straight line is parameterized. We need to find differential displacement vector dr, which is the derivative of the position vector r of t with respect to the t multiplied by dt. This vector is essential for computing the work done by the force field along the parameterization path. So differentiating r of t, we need dr is, as we know, dx, dy, dz is dr. So calculating since x equals to 2t, y equals to c, z equals to 3t. Then dx is equals to 2 dt, dy equals to dt, and dz equals to 3dt. And dr in vector form is dr equals to 2 dt of I plus dt of z plus 3 dt of k. Now substituting into force field equation. To evaluate this line integral, we need to express the field in terms of the parameter t. This is done by substituting parameterized equations of the line x equals to 2t, y equals to t, and z equals to 3t into the original form field equation. After substitution, the force field becomes a functionality of t only. So expressing f in terms of t, substitute x equals to 2t, y equals to 3t, and z equals to 3t into f. So we will get fx what 3x square. So 3 into 2t square equals to 12t square as 4t square. So 12t square. F2 is what x, so 3t. Fy equals to 2 into 2t into 3t minus t, 12t square minus t. So the vector form of f of t equals to 12t square I bar plus 12t square minus t of z bar plus 3t of k bar. Next, calculating the dot product of f into dr bar. So we are calculating fx of dx plus fy of dy plus fz of dz, as dr is dx comma dy comma dz, and f is we have calculated already that it is f bar. So we are calculating both. So we are substituting that. That's it. 12t square into 2 dt, dx is 2 dt, so fx is 12t square. So like that, fy is 12t square minus t, dy is dt, fz is 3t, and dz is 3 dt. And we are simplifying that. 12 to the 24t square plus a 12t square minus t plus 3 3 is a 90 dt. And the final result is we are just adding all these things. 36t square plus 80 dt. So f bar dot dr bar, we have calculated that. So we are evaluating now the line integral. So actually, if in a vector the area under the curve is called the volume, so we are calculating now is line integral, right? Having obtained the dot product, we have already obtained the dot product right now, and now we are setting and evaluating the line integral. So the limits of the integrations are from t equals to 0 to t equals to 1, and corresponding to the start and end points of the straight line. Evaluating the definite integral is the total work done. Setting up the integral c into f bar dot dr bar is 36t square plus 80 dt. Now w equals to, we are integrating those things. So 12t cube plus 4t square from 0 to t. Now w equals to 12t cube plus 4t square minus 12. Like we are substituting the limits. We are applying the limits. Equals to, we are getting that 12 plus 4. Therefore work done is 16. We are getting the work done from this question. See, 36t square. We are keeping 36 outside as it is constant, and integration t square is t cube. T cube, like t cube by 3. T square integration is t cube by 3. 3 into 36 divided by 3 is 12, and 8 into t square by 2. We are integrating this part. 8 by 2 into t square is 4t square. So we are just applying the upper limits and lower limits. So first we are applying the upper limits. So and lower limit, it becomes 0. So 12 plus 4 is 16. Now the results are work done, units, and physical meaning. So we have calculated the 16 work done as 16 units, and the force is measured in newtons and distance in meters, as we all know, and so the work is equivalent to 16 joules. Now we have calculated first, we are parametering first, second finding the displacement, next calculating the dot product, next evaluating the integral. Thank you so much.